So with this question, they said x plus y is equal to 7 and x minus y equals to minus 3. Find the value of x squared minus y squared. Now x squared minus y squared, this is difference of two squared numbers. Now x is a square variable or number in which x and y are represented numbers. Y squared is also a squared number or square variable. Now we could almost say that this is an identity in which we know that if from factorization x squared minus y squared can be rewritten as x plus y, x minus y, or we could factorize it from basic. X squared, what do we square to get x squared? We squared x. So I'm going to write x, bracket it, and square it. Minus, what do we square to get y squared? Y. So I'm going to bracket up this y and square it. Now I'm going to open two brackets. And anything I have underneath small brackets, I'm going to put in either bracket x, y, and I'm going to put plus in this bracket and alternate the sign. I'm going to write minus here. So this would be the answer for if we factorize this. Now, if you realize this is an application question, it's substitution, but it's application in which we need to know that we're supposed to factorize this, then substitute the values. Now, x plus y is equal to 7, so it's 7, and x minus y is equal to minus 3. So we're going to multiply them, because remember, bracket means to multiply. So 3 7s, 21. This is positive 7, so times negative, it's negative 21. We have another application question here in which we're given, so I'm just going to part this off, in which we're given 4p squared minus 4q squared equal to 2r. And they said we're supposed to, they said p plus q is equal to r, show that p minus q is equal to a half. Now, forget about the right hand side for now, let's focus in on the left hand side. 4 is common right here, so if we should factorize out the 4, we're going to have 4 bracket p squared minus q squared equal to 2r. Even though we're forgetting about it, we'll just write it back down. Now, if you realize p squared minus q squared is similar to x squared minus y squared, in which we had x plus y, x minus y. So it's the same procedure for this one. We're going to factorize. So it's 4 bracket p plus q times p minus q equals to 2r. Now, what did they give us? They said that p plus q is equal to r. So wherever I say p plus q, I'm going to replace it with r. So where's p plus q? This is p plus q, so I'm going to replace it with r. So 4 times r times p minus q equals to 2r. Now, remember the question? They said that we're supposed to show that p minus q is equal to a half. Now, right here, 4 times r, right here, 4 times r is 4r times p minus q equal to 2r. Remember, we need to find the value of p minus q. P minus q. So what we need to do, we need to get rid of this 4r. Right now the 4r is multiplied onto the p minus q. So what we can do, the opposite of multiplication is division. So I'm going to divide this side by 4r, and I'm going to divide this by 4r. Remember, anything I do on one side of an equation, I have to do it on the other side. So 4r cancel 4r, so we're left with, on the left hand side, p minus q, and on the right hand side we have what? 2r divided by what? 4r. So now we can cancel the tops, as in we can cancel r with r, and 2 into itself 1, 2 into 4, 2. So at the top we're left with 1, at the bottom we're left with the denominator as half. So this is the answer. This is what they said we're supposed to prove for. That is it. So if you want, you can pause the videos, try them for yourself, and then watch the video to see if your answers are correct. With this particular question, as I said, well, these two particular questions, as I said, they're application questions in which you need to factorize, then substitute, and then do any type of simplification, meaning is either you're going to multiply or divide to solve for a binomial, solve for a particular expression, for example p minus q. So they wanted us to show that p minus q is equal to a half. So this is the procedure. So you can go back over this, because as I said, it's an application type question in which CXC is mainly basing their questions of application nowadays. So it's best to understand whatever you're doing rather than to just know how to do it. When you understand, no matter how they structure the question, once you read it and understand it, you'll be able to apply yourself to whatever the question is. So this is how we prove it.